Hello, I'm Tom Morris, Business Development Engineer with TT Electronics. Today I'd like to talk to you about an interesting new resistor we have. It's our OAR series. Here's what one looks like. It's quite simple. It's really just a resistance wire that's welded to two plated copper feet that are used in a through-hole circuit. Now the nice thing about this is the resistance wire keeps the heat off the board, so the actual solder joints are quite cool. The OAR series stands for open air resistor, and unlike most resistors, we actually have developed this so that instead of conduction as a primary method of taking heat out of the part, this actually uses convection. So we use air to remove the heat from the part and not conduction. The end result is a part which has very, very cool solder joints, which means ultimately very, very reliable, long life. Okay, we've actually got a circuit board we've hooked this up to, and we're going to take some thermal pictures with it. I've got here a simple infrared thermal camera that's made to hook to your iPhone, and we're actually going to take some pictures of it, and you see that, ooh, I'm hot, look at that. So we're actually going to take some pictures of it and see what the relative temperature is to a part actually mounted on a board and used like you'd normally use it in a circuit. Okay, so let's zoom in down here at our circuit board and we'll see what it looks like. Okay, what we have here is just a demo test board, if you will, with our part mounted into it, soldered in. On the reverse side, we have just regular 12 gauge copper wire. Remember, this is a 50 milliohm part, so we're typically carried about 7 3/4 amps to achieve the 3-watt power rating. So let's plug it in. I've also got a little nifty little thermal camera, if you will, and we're going to use this to help determine the approximate temperature on the part. So let's turn on our power supply. Now I already have this set up to right at 7 3/4 amps here, which will give us exactly 3 watts on a 50 milliohm part. Let me see if I can't adjust this a little bit closer. There we go. And using our little thermal camera, we can actually see the temperature on the part. Let me focus it just a little bit here. So you can see I'm looking at actually the top part of it here, and you see, just as we'd expect, the top of the resistor is really hottest, if you will, and down by the terminals, they're actually quite cool. We're seeing a peak temperature of about 140 degrees C at the very top of the part, whereas down at the solder joints, it's a relatively cool, I'd say 65 degrees C or so. Okay, this little thermal camera is really a nice device to have. They're not very expensive, and it's real handy for troubleshooting electric circuits and also just seeing where the heat load is on a PC board. So with that, I'd like to recommend our OARS series resistor. Again, it's cost-effective, high power rating in a small size. It keeps the heat off the board, and also it doesn't take up much space. You see, it's vertical, so you could actually have it jump over other components, so the actual board space needing is very, very small. I'd like to thank you again for watching today. Just as a reminder, TT Electronics has a complete line of resistor products to use. FAEs are standing by to help with the applications for these, and all the data sheets are available on our website. It's www.ttelectronics.com. Thanks a lot. Have a good day.